Hey guys, today I'll be teaching minimum distance between three equal elements. This is the daily problem on LeetCode today, and it was the one yesterday. The one yesterday was easy and today is medium. Now why is it two difficulty levels? It's to do with the time complexity. The easy one, I'm pretty sure that you can get away with the naive solution, right? A pretty bad one, whereas the medium one you would have to do it in O of n, and that was the main difference. So if you could do the easy one in O of n, then you can just copy the same code over. It should work just fine. Now for easy, I'll show the naive problem first because that was the hint given in the part 1. There's two parts here. So in part 1 there was a hint at the bottom. It said use brute force. Now what do they mean by brute force when they give you an array of numbers and you have to pick a triplet, right? Pretty similar to threesome, except this time you're trying to find numbers that are equal, and then you have to see distances and then find the minimum of the distances, right? Now how do we pick out triplets in an arrays like given like this, right? I'll show the brute force first. The best way to pick a single element, right, is obviously doing a simple for loop for I in range len of nums, right, and then all the way to, so this will go from 0 up until n minus 1, n being len nums, right? So we've picked an element here, right? We'll say number 1, I'll just write it for namesake, nums I. Then the next element that we want to find, it would be for j in range, and since you already considered I, now we will start from I plus 1, right? Because why do you can't consider the same one and then say that it's equal. They have to be different, right? And it wouldn't make sense to just keep doing the same one. Now len nums again, so I'll write it out here as well. num2 equals to nums j, and then to do the next one we'll call that k. For k in range, it goes from j plus 1, right? Because now so if you look at it this way, then we've hit I, right? And then we've picked j, then we've picked k, essentially. Now right now I haven't written the conditioning for the numbers have to be equal. I'm just showing you how to pick three elements, right? So len nums, so right now we have 1 1 2, let's just say, and we will say nums3 is equals to nums k, right? So now we picked 1 1 2. Now I would say take a look at this. If you can figure out a hint on how to add a bit of checks, just a couple of checks over here to see how you can find a triplet, go ahead and do that. I'll show you the answer. So now that we have 1 here, the first check we will do is on j, right? We'll say first check if nums1 and nums2 are equal. And if they are equal, then only would we run this for loop, because you would need to first find 2 equal before you find the third equal, right? It just wouldn't make sense any other way around. So we picked a number, we picked another number, we saw if it is equal, then we will go on to picking the third. If not, then we will just go back. We will keep looping until j ends and then I ends, right? So in this scenario we will pick 1, then we would pick the 1, then we would see, okay, it's equal, so we would enter this loop, right? Now we would go 2 wouldn't match, and we would also have to say if nums2 num2 is equal to num3, then triplet. I'll just write that out here for now, right? So then only we have a triplet. So if we have 2, that wouldn't satisfy this condition, right? Until we hit 1. Now keep in mind, since we have these 2 fixated, it would loop through the entire rest of the array before it goes back to looping for j, right? That's how loops work. So 1 1, it will come to 1, and then it would say, okay, we found a triplet, and that's it. Now the question itself, right? I've done pretty much 90% of the question by just doing this the naive way, right? The only additional check that you need over here is when you do hit the triplet, instead of saying triplet, just say calculate the distance at that point. So distance is this formula. I won't write it out completely, right? Just do that. You can have a distances dot append, and then you could have like you could just append this distance, right? So you could make an array outside that has distances, and then you could simply just return the minimum of the distances, or you could just have a simple counter that does like distances is infinity at first, float infinity, right? And then if the distance we got here is less than the minimum that we were at, then we would simply say, okay, make this the distance. So you would also avoid using extra space. This would just be constant, essentially, right? Now the other way to do it, the other way uses 2 patterns, right? Hash maps and sliding window. Now since I've given this hint, I would like for you to look at this and see where we can essentially make this more efficient. Okay, something to keep in mind is that the numbers have to be equal, and if we consider this, then we could say 1 is repeated 3 times, 2 is repeated 1 times. Only this would qualify, right? Because we've seen it 3 times. It has to be greater than or equal to 3 for it to qualify, right? And what would we do, right? Because we need to relate it to the indexes. So what could we do? Think about it. I'll show the answer now. So the first thing we have to do, we have to initialize dictionary. I'll call it scene. I'll put a number here. So let's say 1 over here, right? And instead of storing the frequency, not 3, we won't store 3. We will keep a list. Now in this list, we will put the indexes that we have seen 1 at, right? So what are the indexes? I'll just write it out here. So 1 1 2 1, 0 1 2 3. At what points have we seen this? We've seen it at 0, we've seen it at 1, we've seen it at 3. For 2, we've seen it at 2. Now if you were to loop through this scene.items, right? If we were to loop through that, the only one that would qualify is when the length of the value is greater than or equal to 3. Otherwise they wouldn't qualify, so we would skip over 2. We wouldn't even consider it. Now the second part of this question, we have 0 1 3, right? How do we, if we have 0 1 3, that's already a good distance. But what if we also hypothetically, I won't write out the full example now, but if we hypothetically had 0 1 3 6 and we found it, now we would have to consider this portion first, right? And then this portion, right? And if you've seen any of my previous videos, the one where I explain sliding window, there is basically a fixed size sliding window that you can slide through over here. So you would first consider 0, 1, 3, then you would consider 1, 3, 6. And it is the same thing that I showed earlier. We would say low is 0, high is 2. We'll keep it at 2 because 0, 1, 2 is our window. Our window doesn't exceed size of 3, right? Now we will do another simple for loop for high. Or actually I like to do it this way. So while high is less than length of the value, right? Because we only have to stay within the value. Right? This is value. We will say I j k is value low, value low plus 1, and our window ends by just saying value high. Right? I, j, and k have now been assigned, and we do the same exact thing. Distance equals to absolute, and then you can go on do that, and then you could keep a variable, keep an array, either one, right? It shouldn't, I don't think, unless they give you like an array which has multiple, an array which has multiple distances. You could have a distances array. I don't think it affects your memory score that much, but I would still say just have a constant variable, makes it much easier. And at the end, if distances, right? So if distances, that means the array is full, or you could say if minimum distance not equal to float infinity. That is what we assigned it earlier, because remember, when you do minimum or maximum, when you want to find the minimum, you want to maximize it to initialize it to the maximum value that you can possibly get, which is infinity, positive infinity, right? And when you want to do it as a maximum, then you want to do it to the negative infinity. This is just a trick in Python, right? I don't know how it translates in other languages because I haven't tried it, but like this, and then you would simply return whatever the minimum was, right? If not, don't even need the else, actually, just do return -1, and that's literally enough to solve the question. Now what do I mean by storing the indexes, right? So for people who haven't done 3-sum, to get the initial dictionary as I've shown, you would do for I and enumerate nums. What is enumerate? So enumerate is basically, we've written I, we've written n, right? This would map out, so if you had 1, 1, 2, 1, it would map it to 0, 1, 2, 3, 1, 1, 2, 1. You would have access to both of these values at once instead of just doing a for I in range, right? You could technically just do a for I in range and then make n equals to nums I, right? Same thing, this is just a bit of a shorthand, makes it easier. And we would say scene n dot append this index to the default date. Oh yeah, by the way, I have to show that as well. So there's this thing called import from collections. Import default date. This is a thing that you can import and you just use it. So how you use it is, you will say scene equals to default make it a list, right? What this does is, so whatever value you initialize, so let's say 1, it would basically look like this at the start. So any value that comes in is now a list. So you can simply just do append scene n dot append, and that would append, because scene n would be like accessing the array, right? It would be like this. Then you just simply did a append, like an append on a normal list. That's how it would work. So at the end you would get something that looks like this scene, right? And then you follow the same thing I did over here. You loop through the scene.items for kv in scene.items, figure out the len. If len, right, then only we will consider it low high, that, and also just increment low plus equals to 1, high plus equals to 1, because we want to keep the window moving, otherwise you will hit TLE. Alright, that should be it. Pretty simple. Best thing to do is first come up with the naive and then move on.